This is an optical encoder which uses an LED and a light sensor and an optical strip, which is a piece of transparent plastic with some very fine lines printed on it at very small, evenly spaced intervals. This is a circuit board that I have designed and had printed and made. It's based around a Texas Instruments MSP430, which has 16K of flash RAM, 512 bytes for the stack and the heap, and runs at 16 megahertz. The chip has two programs running on it, which I can switch out of RAM and load at will. It uses an event-based system to allow you to queue events and have more control over the timing of system processes. That all fits within the 512 bytes of RAM at runtime through dynamic memory allocation tricks in C++. The two programs currently running on it are one to count clicks on the optical encoder, which works like a rotary encoder. That can then be used for a ruler, and the other is to use the internal temperature sensor of the MSP430 to give a readout in the three common temperature scales. It's running at 3.6 volts at the moment, powered by an outboard power supply, but will eventually use batteries and should be able to run up to 5 volts. Anyway, so now I'm going to demonstrate the ruler function operation. So I'm now going to pull the encoder strip through the optical encoder. So that's about halfway. I'm now going to reverse the direction of the encoder strip, and we'll see it count in the other direction. So every time the ruler moves, an interrupt handler creates an event in a queue, which is processed later during the main program loop. This allows us to put minimal operations within the event handlers, thus ensuring they complete before the next clock cycle. Okay, I'm now going to demonstrate the second function of this. There are two buttons soldered onto the board. By double clicking one of them, I can access the next function. So this will be the temperature function. There we are. So this is the current temperature in Fahrenheit, Kelvin and degrees centigrade, and I can switch back to ruler mode by double clicking again. There we go, and the ruler's reset itself because it's a new instance. And then I can switch back to temperature mode. Now, the nice thing about this is that it allows us to write as many different modules as we like to fit within inside the 16 kilobytes of program storage RAM, flash RAM on the chip, and we can load in small modules, as many as we can fit into the flash RAM at will. So this enables us to greatly expand the functionality that we can provide with just 512 bytes of RAM.